Okay, so now that we've got all of our samples, we are actually going to make some slides. Now, first thing with slides, it's always important to label them. And you want to label the backs of them so that you know what is on there and so it won't run off when you stain them. I'm just quickly doing this for each of the organisms we did. I'm also making the ones for the acid-fast endospore stain. Those ones are a little bit different staining procedures, so I'm going to show you guys how to do those as well. So there you go. You can see the labeled things. They don't have to be super specific. Now, when I like to do these, I like to use a loop that helps create a nice even spread. And one of the things that you can do is add a little drop of DI water so that it helps smear everything around evenly. Now, you only want to put like about a half a drop because it takes long to dry, and so you want to be careful with that. You don't need a ton of bacteria, you just need a little. The more bacteria you put on, the harder it's going to be to actually visualize this properly. And the more water you put on, the longer it's going to take to dry. So remember, you want a nice even smear and just let it sit in here and get a nice good spread out, an even spread out. If you don't do a nice even spread out, you're not going to be able to get a very good result. Which I know it's kind of hard to see. You can see that there's the liquid on there and it's slowly going to dry. I'm not gonna make you guys wait and watch the drying because that seems boring. But I am going to get the rest of these done. Now that was the endospore one, that's just one bacteria. The other one I'm going to do is an acid-fast stain, which is two different bacteria. It's it's Staphylococcus aureus and Microbacterium smegmatis. So you can see the difference between endospore positive and an endospore negative bacteria. Now the trick with this is I'm going to only smear about half of it. You want to have a nice split slide. You don't want to have them perfectly overlapped because there's actually so many foci from the Staphylococcus aureus one that it's going to kind of mess things up. And it's just not going to look very pretty on the slide. So there's only going to be a teeny tiny amount of overlap. So one side's going to be pretty much purely just the Mycobacterium, the other side is just going to be mostly the Staph aureus and a little bit of overlap in between. And the reason why is, again, if it's too thick, it's not going to look right on the slide. You won't really be able to differentiate anything, which is not super helpful. All right. The rest of these are just individual bacteria. No special strategy. Remember, you don't want to have a very thick smear on here. You want it to be light, see-through. You don't need a ton of bacteria. But you do need enough bacteria to visualize it properly, which is one of the issues. Sometimes people put too little on there, or they won't let it fully air dry before they do their stuff. And then if it's not fully air dried, it's just going to kind of break apart when you guys actually do the staining. Now the last part of this, which I'll show you guys, is heat fixing. Now, heat fixing is when it's totally dry and it fixes it so it doesn't kind of come off when you guys actually do the staining. It'll basically come off really easily, the bacteria, if it's not heat fixed. It also helps kill the bacteria. So if you have anything that's dangerous or anything that's going to be a potential hazard, this will help limit any kind of activity because they'll all be dead. Bacteria also like to produce a type of enzyme called lysozymes. And what they do is they lyse other bacteria. But if they get stressed out, sometimes they'll start lysing themselves. And so to preserve them, we will heat them to heat fix them, and that'll help prevent them from kind of blowing up, essentially. It's a weird little thing bacteria do. So if we want to keep a slide for long term, we have to heat fix it. Otherwise, it's not going to work very well. So I don't know if you guys could see, I'm just smearing it back and forth like this. Trying to spread it out. It doesn't need to stay in a very central area. It needs to spread out so it dries faster. Drying fast is the most important thing. If you notice, in between each of these, I am decontaminating my inoculating instrument. The reason why is because I don't want to contaminate my stock cultures, the things that I use to make these with. Now, what we're going to do is we're going to sit here and watch them wait. Okay, I'm not going to make you guys watch them wait, but I will show you guys a couple of interesting little things you can do to kind of help hurry them along. One of them is, of course, just to make it properly begin with so that there's less water. The other thing you can do is you can take some paper towels and just kind of fan them, and that helps evaporate the air. And we'll probably have one here ready to go in just a second, and I'll show you guys what heat fixing looks like for that one. All right, we're going to cover what heat fixing looks like real quick. So you can see the back decelerator, which is on. It's glowing orange. Now this little guy is really red hot. You've got these little trays that have slats in them that we can use to heat fix them. And we're going to only keep it here for a couple of seconds, between 10 and 20 seconds. And basically what it's doing is it's fixing the bacteria, it's denaturing the proteins, helping them stick to the slide, making sure the bacteria are dead, and all that good stuff. Once it's done, take it off, and we're going to let it sit. And we're going to repeat this with the next other slides once they finish drying. That one just dried first. And then we will get with the staining. All right, so here's our staining area. You can see we've got these metal racks over a sink. I'm just going to lay the slides across them. Now, the most important part here is to make sure, A, that you're putting the right slides on there. So I accidentally put the Endospore and Acid Fast on there first, which is a dumb idea. The other important thing is to make sure that your slides are bacteria side up. You'd be surprised at how often people forget to do that. Now, while that goes, you are going to do the first set of steps for your stain, and that is going to be using the dyes. The first one is this guy, which is crystal violet. And so you just need to put enough to cover where the bacteria are on the slide. You don't need a ton, but you do need to cover everywhere that there's bacteria. If you don't, what ends up happening is certain bacteria will get stained, certain areas will get stained, and certain areas will not be properly stained. So you want to have everything properly stained. So hopefully you guys can see that. Actually, I'll just move it. And we're going to let it sit there for about a minute. Now the next thing we're going to do is we're going to do the acid fast endospore, which have to be heated. I'm going to do that in tandem while we do this one. Got a little beaker of heated water right here. And we've also got our slides. Now, normally we don't do these both at the same time, but we are today, so you guys can see the slides there. Now, one thing that we need to do, which I left all the way over here, take our crane buddy with us as well, so he can hang out and keep us company, is we need to add paper towels and the dye to them so that the dye stays in constant contact with the item. So I'm going to do that real quick. Hold on. Helps if you have two hands. Unfortunately, I do not have a camera that lets me do that. put the paper towel on top of the bacteria and I added a drop of dye. The one on the right is our Endospore, and that's got malachite green on it. Malachite green will penetrate the spores. And the other guy is our Carbol Fusion. Now, you want to keep these nice and moist, and we want to make sure that they're in good contact with the paper. If we don't, then they aren't going to steam properly. So we're just basically letting the steam hit them and help it go in there. And so I'm going to start 10-minute mark. I won't make you guys sit through this, but I will start doing the other slide stuff now so you guys can see it. Get that out of the way. All right, so our first set of stains for our gram stains, you can see the dyes on here. We need to rinse it off, so we're going to gently rinse it off with DI water. We're just gently spraying it. We're not trying to blast the bacteria, we're just trying to get the dye off. That's all we want to do. And you basically just kind of want to do it until the slide runs mostly clear. We're looking for the slide to not have any more purple liquid coming off. Okay. All right. So we did that. Now we're going to add in our next thing, which is our mordant, which is grams iodine. Its job is basically just to sit there. So it looks like this is just normal iodine. Its job is to sit there and help the crystals form inside the cells that are gram positive. If we go real quick back to our dyes, you guys can see them here. This one's looking a little dry, so I'm going to moisten it a bit. And this one's definitely very dry, so I'm going to add some more. So these dyes are interesting because one of them is a phenol-based dye. So I like it to evaporate very quickly, so you kind of have to constantly reapply. And if you guys see this white guy right over here, his job is to suck up air to make sure that the fumes aren't just kind of going wherever. So his job is to kind of suck up that steam so that fumes aren't just going everywhere. Okay, I know, it's thrilling. It's like watching paint dry, but it does take a little bit of time. And that's about enough time for the mordant, so we'll let the mordant come off now. Just hold it there, and basically do the same washing technique as I did before, rinsing them off. If you don't see anything on your slide right now, it's fine. Don't worry about it. There's more steps. Okay. Now we are going to decolorize. And the way we do that, while I'm talking to you guys, I'll add some more dye to my slides up here on the water bath because they dried out again. See how quickly they dry out. It's pretty fast. I'm going to take alcohol, in this case about 95% alcohol, and we're going to put it on the slide. Now, I am not going to let it be on the slide for a very long amount of time. It's actually only going to be on there for a short amount of time. I'm going to rinse it off right away. What you don't want to have is it to stay on there for a very long period of time because you're going to over-decolorize. So about 3 to 5 seconds. There we go, I've hit my 3 to 5 seconds. I'm rinsing off the dye. So nice and clean. And you only want to do these one at a time because it goes by very fast. And I'm shaking off the excess water. And 3 to 5 seconds go by. I'm going to then rinse it off. For this guy, just putting enough on the side, cover it, and then I'm going to quickly rinse it off after a few seconds. And this last guy. So it's not a lot of time. This is the most important step, but it doesn't require the most amount of time. It is actually one of the least amount of times. And time to reapply some more dye. Okay, so last step, move this out of the way, is saffronin, which is this guy right here. It's a nice red one. It's going to counterstain or a secondary stain. Both names are technically correct, and I'm just going to put this dye right here. We're going to let it sit for a minute. And while it sits, we're just going to talk and chill while we wait. How are you guys doing? How's your day? Is your day great? Oh, that's terrible. To pieces, you say. Okay. Now, while we let that sit, just be aware that all we're trying to do right now is counterstain the bacteria that did not absorb the gram-positive dye. So anything that's gram-negative will absorb the counterstain because it'll have lost all the gram stain, the crystal violet, and the mordant added to it. We'll have lost all of that when we did the decolorizing step. So now that we've done the decolorizing, we've gotten done with the decolorizing step, we can now do this next step where we let it basically sit and chill, and only the ones that don't have any dye left in them will take up this new dye. The gram-positive ones might have a little dye stick to them, but it won't really affect the color too much. Also, while we're sitting here, I will show you the cool carbofusion. You guys can see the acid-fast one. It's got a nice little, somewhat in the water. That's not good. It's got a little green tinge, which is kind of cool. We don't know why it does that. It just does. So there you go. Neat little thing. All right, now so that's been a minute, or it hasn't been a minute at all. I don't know. We'll find out. Maybe I'm doing a horrible job. So you guys will see my terrible slides here in a minute. So I'm just taking the slide off and I'm rinsing it in the water, same as before, same process. Just rinsing it until it runs clear. Same here. Not blasting the bacteria, I'm letting the water run down the slide, not trying to blast bacteria off. That's actually a really common issue people do. Sometimes people will dip these in water instead, which is more gentle, which is true. It's just more waste and more things that you kind of have to keep track of. Plus people knock it over all the time, which is great. Okay. Now we got a bunch of these. I'm reapplying dye yet again because that's how quickly this thing loses its dye. Very. All right, the next step is blotting with bibulous paper. This is bibulous paper. It's absorbent. It's meant to, you can see kind of the multicolor of other people having stained in here. It's meant to basically just wick off any excess dye. You're not trying to wipe dye off. You're just trying to blot any excess dye or liquid that's on here. And that's all we're trying to do. So you just fold it over like this and you just press gently to blot off any excess dye, which helps quite a bit. Now, the worst thing to do is do that in your hand rather than on a table, because your hand is notoriously not flat and glass slides do not like to bend. So it'll snap in half and then you'll have it back in. So make sure, if you guys ever do this in real life, not to do that. You can see my slides come out and they don't have any excess dye on them, which is great. And you guys can see it here. Okay. So we're going to do our other sides real quick. We're going to take them off the hot plate like so. Take them off. I'm going to take the little paper towel bit off. Throw it away in the trash. Same thing for this other guy. And we're going to, of course, turn our water off so it stops like baking. Okay. So now we're going to do some other steps. We'll do carbonyl fusion first. Carbonyl fusion is actually really easy. First things up, we want to rinse it off because we rinse off between each step. So we're just going to add some water here and just kind of let it drip down everywhere until we don't see any more dye. We're bound to see some dye. That's fine. Okay, now that it's dripped off, we are going to add our decolorizer, which is this guy, acid alcohol. And what looks very similar to the other one, but this one has acid in it. And this is what makes it acid fast. Now you have to add this on here for a little bit longer. What it does is it removes the dye even under acid conditions. That's why if it holds on to it, that means that that bacteria is acid fast. It's going to hold on to the dye even under acid conditions. So we're just going to let it sit here for a couple seconds and really give it a chance to do its magic. Once that's done, we're going to rinse it off. You can see a lot of the dye has come off of that now that we've let it sit on there for a second. And now we're going to color counterstain. Our counterstain is methylene blue, which is this guy right here. And methylene blue will just counterstain anything that's not an acid-fast bacteria with a nice blue tinge. And we'll just let it sit on there for a couple minutes. 2, in fact. While that's going, we will decolorize our endospore stain, and actually the decolorizing process is actually just water. It's not anything special. It's just decolorizing with water. The dye comes off really easily for things that are not endospore positive. It's very convenient. For our purposes. Okay. We'll counterstain this one with safranin. Now, the clever among you might note that Bacillus megaterium, which is the bacteria that we use to make this with, is a gram-positive. And we are using safranin, which we use in gram stain to counterstain a gram-negative. Well, the reason why we're doing that is because it will take up the dye as long as we're not decolorizing it really readily. And so we're only cared about colorizing the vegetative cells, not the spores, because we don't have to force the dye into the vegetative cells. They'll readily uptake it. Okay, our acid fast has sat there long enough. We can decolorize it. And our safranin as well. Decolorize that one as well. Bacteria, they're bacilli, they're in a random formation. It's because they are motile bacteria, if you guys remember that from the tubes that we did. So they're going to have kind of an interesting red tinge to them. Now, this picture is not the best because I'm taking it from a camera, projecting it to a screen taken with another camera. This is not exactly how it looks, but it's pretty close. It's color corrected, so it should look mostly right. The next one we're going to be talking about is Micrococcus luteus, and you can see it's got these nice, bright purple foci. They're very easy to see, and they come in this tetrad arrangement. Now, it's very important to note that you have to hunt around and really double check things. Make sure you have more white space than bacteria, because this one often looks a lot like Staphylo if you aren't looking carefully. And I'll show you guys a picture elsewhere on the slide. And you can, to the trained eye, can detect the tetrad formation, that little pattern of 4 over and over again. That is something that doesn't just occur randomly. And you certainly don't see a whole bunch of them throughout the entire slide. So if you start seeing a whole bunch of those patterns of 4, you can pretty much guess that that is going to be a tetrad formation and not a Staphylo one. The next one we're going to be looking at is Pseudomonas aeruginosa. This one is a rather interesting one because it's also gram-negative. So it's much like Serratia marcescens. It's a little bit bigger in size, and you can actually see that it's got this nice red coloration as well. It's a little bit more densely packed in the image that I have for you guys, but you can definitely see that red bacilli formation, so that means it's a gram-negative. It's also important to note from this that it is also random, so it doesn't really have any pattern. It's also modal bacteria, so it's going to move around on its own. There you go. So that's Pseudomonas aeruginosa. And the last of the gram stain that we're going to look at is Bacillus subtilis, which is a gram-positive, as you can see here. It's a bacillus, and its arrangement is strepto. You can see these really long end-to-end chains. Now, it's really important to note that these ones are end-to-end, and they're in these long threads or chains, and different bacillus species tend to have different arrangement looks to them, even though they're all strepto. So some of them might look like hairs connected end-to-end. Some might be in very small patterns of short bacilli. Some of them might be longer bacilli, so you might see like the ones on here. But you guys can see a pretty good image of what they should look like. Next up, we have our acid-fast slide. And you can see the Staphylococcus aureus, which is a gram-positive organism, but non-acid-fast is going to be the purple, bluish-looking foci. And next to it, you should see, or interspersed amongst it, is the bright red acid-fast bacterium, Mycobacterium smegmatis. Now, Mycobacterium has that mycolic acid covering, so it absorbs that phenol-based dye, and it's going to retain it because we put the heat to go inside of that waxy layer, and it's going to retain even under acid conditions. Now, if you guys remember, I gave you guys a warning in the lab lecture videos where I was like, don't put too much there or cross over. I accidentally put a little too much, and so we didn't get a great image, but you can see in some of these images that I have up on the screen, individual little bits that are reasonably, have the reasonable amount of the red bacillus. Of important to note, the red bacillus that you see here is an example of palisade arrangement. That is a very specific type of arrangement. So it's kind of stacked next to each other. They sometimes like to stack on top of each other in a three-dimensional array, so make sure you guys keep that in mind. That's an unusual one. The very, very last one that we're going to talk about is our endospore stain. Endospore stain didn't turn out super great. It's a little bit hard to see the spores. They're kind of like this light green coloration. It didn't spore as much. I'm going to try to do another slide for you guys sometime, but you can kind of see it in here. It's in between or inside of mostly the vegetative cells, which are a bright red coloration. Remember, this is just a counter stain to visualize the bacillus that are surrounding the spores. What we really care about is the presence of the spores, which are stained green through malachite green. And we had to penetrate the spores using heat and the special stain for malachite green in order to do that. And you can see it's got a nice bright green color periodically, and these end-to-end bacillus-shaped bacteria. So if you guys remember what that arrangement is, it's strepto arrangement. So if you've got end-to-end, it's strepto, and that's what it looks like here as well. All right, thank you guys for watching, and I will see you guys later.